There, Cougar Academy Algebra 2, and welcome to Lesson 2.7, How do you solve absolute value equations and inequalities? So, solve the following absolute value equations. Big thing to remember with absolute value, here is the trick of the day, is there are two problems. These are a 2-for-1 deal, 2-for-1 problems. It is a bargain for you guys. So remember, if you have absolute value, and that is these bars here, you want to first isolate the absolute values. Isolate the absolute value, okay? And in this particular problem, that's already done. We will see other ones. Once you isolate, then you are going to split it up. Split. So I like to draw the little arrows. What we're going to do is we're going to split and flip. Split, flip. 3m is equal to 6. That is one of the equations we're going to split it up to. And 3m is equal to -6 is the other. So that's the flip. What I mean by flip is you flip the sign from positive to negative or vice versa. All right, because absolute values, remember, they change positives into negatives, negatives into positives. Okay, actually, they change positives to positives and negatives to positives. That's what I meant to say. Now, once you have that, you just divide 3, m equals 2, easy peasy, and m equals -2, divide by 3, boom, 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 boom. Okay? Now, sometimes, not all the times, not most of the time, I'll have extraneous solutions. So it's a good idea to check each solution. And you could do it mentally or you could do it on paper. But all you do by doing that is you're just going to substitute these values, 2, into m. So if I took the absolute value of 3 times 2, well, is that equal to 6? Well, 3 times 2 is 6. Absolute value is still 6. So that one's good. If I check the other one, 3 times -2 is equal to 6. Well, we have -6. But since they're absolute values, they make it +6. And 6 is equal to 6. So it checks out. So both of those are good. Check. And if it wouldn't work, we'd call it extraneous. So check for extraneous. I think that's extraneous. E-O-U-S. I think that's how you spell it. Extraneous. Yeah. Okay, so 2-for-1 problems. Isolate, split, flip. Check for extraneous. I guess there's solve in between there. And then check. Okay? I'll fix that in the next part. So maybe solve. And then this be step 4. That makes it better. Okay, so let's check out what's going on over here. All right, same idea. Absolute value, isolated, so it's good to go. Split it up, -4m equals 16. Boop, 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 boop. -4m equals -16. Key thing, you do not change anything about what's inside the absolute values. Notice it's still -4 in both cases. The only thing that you flip is the sign on one of your splits. So we split it up, and then we're just going to divide. M is equal to -4. M is equal to +4. Now, don't always assume one's going to be negative, one's going to be positive. We'll see some in the future here that that's not the case. If you were to check those, I'll give you the benefit of the doubt. They both work out. No extraneous for those. Okay, moving down, turning up the heat a little more challenging. Now we do need to isolate. So what I meant by isolate the absolute values is first we want to move this -2 to the other side by adding 2. So it's 9. Is equal to absolute value. All right. At this step, it's isolated, it's ready to go. We can split it up. So we have 5b minus 6. Again, don't change that sign. Don't do it. It's equal to 9. Split. 5b minus 6 is equal to negative 9. That's the flip right there. And then we're just going to solve. Boom, boom, boom. Boop, 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 boo. How's everyone today? Hope you're doing well. And I hope that math is pretty easy there. B is 3. Add 6. Add 6. Negative 9 plus 6. That is negative 3. I almost had a moment there. Don't tease me. Yes, I used my calculator. I'm sure some of you did at home too. It's a positive. No, I got it right. I just typed it in wrong. Okay, 5b divided by 5 divided by 5. Oh no, we get a fraction. But that's okay. We'll just leave it as a fraction. But notice we have two different answers. One's not positive 3, one's not negative 3. We have a fraction, so don't always assume it's just plus or minus. Now, it might be a good idea to check, maybe even just this one, absolute value. And when you're checking, substitute it into the very original. So I'm putting it into this equation. Okay, so my check is absolute value, 5 negative 3/5 minus 6. Well, that's negative 3 minus 6, which is negative 9. Whoops, I forgot the minus 2 at the end. Negative 9, the absolute values, I'm just going to erase them because that would become positive 9. And then minus 2 would equal 7. Okay, so 9 minus 2 is equal to 7. It checks out. So both solutions, again, you could check this one. I would like you to when it comes to practice, but for sake of time on the video, I will just let you check that on your own, so to speak. But they both work. Okay. Number 4. Number 4. What is that? Okay. It's not too scary. Okay. You can also think of this, the way it looks is a little intimidating, but we can think of it as 1/8 times 8 minus k equals 2. So you can feel free to rewrite it. Doing that, now another thing with absolute values is you do not distribute. Don't ever distribute to an absolute value. Absolutely don't distribute. So if that was your thought, it's okay, you may not have known, but don't distribute. Instead, when we deal with fractions, multiply by the reciprocal. So I'm going to multiply each side by 8. Magically, that just cancels the fractions out. I end up with 16. The absolute value, nothing gets impacted by that. It's isolated, so we can split. 8 minus k is equal to 16. Bada boom. 8 minus k is equal to negative 16. Negative 16. And go from there. Now, let's solve. Minus 8 minus 8. So it is 8. Negative k. And divide by 1. Negative 1. And k is equal to negative 8. On the other side, subtract 8. So that's negative 24. Again, k is equal to 24. They do both check out. All right, so I'll save you the time there. They work. Check, check. Good to go. Some problems here. So now we just have multiple steps. Again, first idea, isolate. So let's get the absolute value all by itself. You want to add or subtract first. So I'm going to add 8 over. 48 plus 8, 56. Again, don't distribute. It's tempting. But now we can multiply each side by 1/7, or think of it as dividing by 7. And that gives us 8. So 8 is equal to absolute value 7 plus 3m. Now it's isolated. Split it up. Again, don't change the plus inside the absolute values. Subtract 7. M is equal to 1/3. So we divide by 3. Subtract 7. Negative 15. And M is equal to negative 5. Okay, once again, save you the time. They work. They won't always work. I'm just being generous, and they work here. So I would like to see some of your checking. Again, you could really do them in your head for the most part, and they'll work out for you. Last of these types, then we move into inequalities. If you want to pause here and try, that'd be fantastic. So go ahead, do that, come back, see what you got. I'm just going to start by adding negative 3. Divide by 5. Chop it up. 2 problems. 8k plus 4 is equal to 4. And 8k plus 4 equal to negative 4. We'll subtract 4, so it's 0 is equal to 8k. This is a good one. Minus 4 minus 4. Negative 8 is equal to 8k. On this particular side, we'll divide by 8. 0 is divisible by 8. It is just 0. So again, don't be afraid of 0 as a solution. K is equal to 0. On the other side, it looks like we'll get k is equal to negative 1. If you're concerned with either of those, well, let's mentally think. 8 times 0 is 0 plus 4. Okay, it's just 4. So 5 times 4 is 20 plus 3 is 23. So I did that one mentally if you were listening. 8 times k, or 8 times negative 1 is negative 8 plus 4 is negative 4. A negative 4 in an absolute value makes it positive. So 5 times 4 is 20 plus 3 is 23. They both work. All right. Videos today, this lesson's a little longer, so feel free, stretch, take a little break here. If you want to do the practice problems of just those, that's fine. I'm going to move on just to the inequalities, okay? And really, there's a few more problems. They're really pretty much the same idea, but there's one extra trick here. Okay, so we're solving and we're going to graph. Absolute value p minus 3 greater than or equal to 2. Okay, so the key thing here is with greater, we always know this is going to be an or statement. Greater means it's an or statement. So when we split this up, you still want to isolate, but we have p minus 3 is greater than or equal to 2. So this is the splitting step. Or, and we are going to do something with and, so make sure you specify that, greater, p minus 3 is less than or equal to negative 2. Now, take a look. Think to yourself, what all changed in this second flip? The negative 2, like before, but also the inequality sign. You have to do a double flip. You have to flip the sign of the number and the inequality, and you do that on the same particular side. Okay, so a double flip with inequalities. Once you do that, it's pretty easy because you'll just do the same idea, is solve each. So we have p is greater than or equal to 5, or if we add 3, P is less than or equal to 1. Okay. A few things with graphing these. Greater than or equal to 5. Here's 5. Remember, that would be a solid line or solid dot. And it would be 2. I'll use it in orange. Everything greater than that to the right. We'll stick with pink. Less than or equal to 1. Solid circle at 1. And going backwards, it would be that there. Okay, so those are our solutions, and that's the graph for one of our inequalities. Remember, greater, greater. Here is an example of a less than, and it's an and. So you can think less than. Okay, and that's always the case if you have less than in an absolute value. It's already isolated, so I'm just going to start flipping and switching. So less than 16 and m minus 9 is greater than negative 16. So I did that double flip. From there, add 9, 25, is that it there? Yep, is less than m, or m is less than 25, sorry. And add 9, negative 16 plus 9 is negative 7, and m is greater than negative 7. So in two colors here, I'll show you. Going in this direction to the left is less than 25, so I'll just kind of draw it here. Going to the right is negative 7. Okay, and there is a reason I'm not drawing them directly on the line. Remember that an and problem is only where each crosses one another. So if you notice, the pink one starts here, so that means we aren't concerned with anything on that side. So we go here, here, here until they're both covered, they're both covered, they're both covered, and then right at 25, they stop. Those would be open circles. But and is where they're both in common, okay? So just be careful of that. Okay, so less than. Few more of these, same idea. Now we have a little more work. Okay, we just build on our skills. So before we decide anything, let's just isolate the absolute value. That just means I'm subtracting 8. Okay, at this point, we have an and or an or. It is less than. Okay, less than. So we break it up. Negative 4 plus x less than or equal to 11. And negative 4 plus x greater than or equal to negative 11. Going to highlight again the double switch. Add 4. Add 4. 15. Less than or equal to x. And add 4. Add 4. Negative 11 plus 4. What is my calculator doing? Negative 11 plus 4 is negative 7. Less than or equal to x. Let's graph both of those. It's an and problem, so less than or equal to 15 would start about here and go to the left. Greater than or equal to negative 7 here to the right. And is where they're both involved. So, and we do have solid circles this time. And all the way up to about 15. Okay. So that is that one. 10. Our good old fraction example. So remember, it's really equivalent to 1/6 absolute value negative 5b greater than or equal to 2. So if we just multiply each side by 6, that'll fix it. Absolute value negative 5b greater than or equal to 12. Split negative 5b greater than or equal to 12. Negative 5b less than or equal to negative 12 divided by negative 5. Sorry. 12 divided by negative 5. I just want to get an idea, since we're graphing, what it is as a decimal. B is greater than or equal to 2.4. Negative 2.4. B here is less than or equal to 2.4. Now, boom, I actually made a mistake here, okay? So, key thing, before you call me out on it, I'm going to fix it here, but I divided by a negative. Okay, you need to remember, if you divide by a negative, don't make this mistake, you also need to change the signs. So I'm going to change the direction of these signs real quick and learn from that mistake of mine that you want to do that when you divide by a negative. Okay, so greater than or equal to divided by a negative becomes less than, and other direction here. Okay, so make sure if you divide by a negative, you change the sign, and you do that all the times. Divide, change the sign. Divide by a negative, only a negative. Positive, you can keep it the same. That also applies up in the original step. Had we multiplied or divided, so multiply or divide, you would have to change the sign there. Okay? So now we have B is less than or equal to negative 2.4. Okay? Negative 2.4, about here-ish. Okay, I won't be super picky. I know that's probably more so the 5, but or 2.5. That's okay. Greater than or equal to positive 2.4 from here. Also, I forgot to write it in there. This is an or problem because we have a greater than sign. Okay, so do yourself a favor, write that down first. Remember, divide by negative. You're going to change the sign. Okay, what do we got? 2 more problems. Let's do them. Okay, I believe in you. A longer lesson, but hey, sometimes we gotta mix it up. So gonna add 1 to each side. Absolute value, negative 2 minus 9p. And if you're getting the hang of it, you can go faster than me, but do please check your answers at the end at least, okay? And that'll be good. Alrighty, less than. So I'm gonna write that for myself here. And negative 2 minus 9p less than 83. Negative 2 minus 9p greater than negative 83. The double switch. Add 2. (85) divided by negative 9. Dividing by a negative means I better change that sign. So p is greater than about negative 9.4, repeating. On the other side, at least this side turns out to be nice. P is less than positive 9. Remember, change the sign. So graphing, be careful. It looks like they're going by 2s. So this is 2, 4, 6, 8, 10. And this is 2, 4, negative 6, negative 10. Why exactly they did that, not entirely sure. Let's see here. So less than 9. 9 would be about in here. Traveling to the left. Greater than negative 9.4. About here. Traveling to the right. Again, for and problems, it's only where both of them are the same. So or equal, so it would actually be, that'd be an open circle all the way to there. Okay, so take your time and look through that one. All right, let's see what's going on. 5k plus 5 in the absolute values, less than or equal to 25. Subtracted 2. Split it up. Looks like I have an and. Less than 5k plus 5 less than or equal to 25. Just going to do it one at a time here. Looks like k is less than or equal to 40. No, 44. Just 4. Just 4. And so 5k plus 5 greater equal to negative 25. I'm going to subtract 5, negative 30, divide by 5. K is greater than equal to negative 6. Okay, let's check it out here. Negative 6 greater than or equal to, and okay, so I'll draw it to the right. Less than or equal to 4. To the left. And the only ones that are really important are from negative 6 to positive 4. When you're answering these, if you only want to include that as your answer part, that's perfectly fine. Okay, I don't mind that one bit. So great job, guys. I know they were longer, but hey, you made it through. Practice all those, especially a lot of little things with the flipping and negative. So great job again, and have a great rest of your day.